Hi everyone, it's Sharmila here from Can Do Teach, and in this video I'm going to be talking about the terminology that we use in algebra. So it's around this time that maths goes from being mostly numbers to mostly words and letters. And so if you're already quite familiar with algebra, you'll already have a rough understanding of the words that come up quite often. So this video is just a good chance to check in and make sure that your understanding of those words matches up with what the technical maths meaning is. So we're going to look through these words, and I don't want you to have very technical definitions of them, but I'm just going to talk about what I as a maths teacher mean when I use these words. Okay? So pause the video right now and just have a think or write down what you think each of these words mean, and then you can see how that compares with my meaning of them. Okay, so pronumerals are the letters that we use to represent numbers. So X or even A, B, or C. So it's any letter or symbol that we're using as a placeholder for a number. And the important thing to understand is that the reason we use different pronumerals is that each letter represents a particular number. So if a letter appears multiple times, all of those ones mean the same number. So if I have X plus X plus X, that can't be used to represent 1 plus 2 plus 3. It has to be 1 plus 1 plus 1 or 3 plus 3 plus 3, something like that. So all of the X's in the expression mean the same thing. So now variables are similar to pronumerals. They're still letters that represent numbers, but more specifically, they represent quantities that can change. So I might say X represents a particular quantity, and that quantity is a number that can go up and down. Okay? So variables are very commonly used in science, and they're also the types of quantities that we represent on the axes of graphs. So we might graph a variable X versus a variable Y. All right, and talk about what happens when those variables have different values. All right, so a coefficient is a number that multiplies a variable. So I could have 3x, and so 3 is the coefficient of x. All right, and this is where we kind of see the difference between pronumerals and variables a bit, because I can have a term like ax squared. And in that case, the a is my coefficient, and the x squared is my term or variable term. All right, so a in this context is understood as a number that doesn't change. So it's just a particular value, whereas x is a variable that can represent a range of values. All right, so that leads into our concept of a constant. So a constant is again a number that doesn't change. So we can have pronumerals that are either constant because they represent a particular number that doesn't change, or variable because they represent a quantity that can change. Alrighty? Now expressions and equations are quite similar. The difference is that equations have an equal sign in them, whereas expressions don't. So I can have an expression like x times x plus 2. So I can say that this expression describes the area of this rectangle. All right? Whereas if I write an equation, area is equal to x times x plus 2, that's now an equation because it's a statement that includes an equal sign. So equations and expressions are mathematical number sentences, right? So it's how we translate a big worded sentence or worded problem into mathematical statements that are quite concise. All right, now terms are individual parts of an expression or equation that are added together. So if I have x squared plus 3x plus 1, I'd say that this expression has 3 terms. All right? So they're individual chunks that are added together, And then I can say certain things about those terms, like this is the constant term. or this is the x squared term, or 3 is the coefficient of the x term. And the important thing to notice about distinct terms is that they have to be added. So if two things are multiplied, that's actually the same term. If I have a times b, ab, that's a single term. Okay? It's only when I add it to something else that I've got two distinct terms. Okay? And finally, we've got like terms. So like terms are terms that are the same type, so I can actually combine them. So for example, if I have a squared b and b a squared, I know that because the order in multiplication doesn't matter, they're actually the same type of term. So I can rewrite this as a squared b plus a squared b. And now I know that those two chunks are the same type of number. So I can just add those together to get 2a squared b. So we call terms like this like terms. And it's only like terms that we can combine. Otherwise, we have to leave them like this. We can't collect any of them up. So these are all the names of things that we talk about in algebra, so the nouns. This list is more the doing words, so the kind of words that in questions they'll tell you simplify this or solve this. Okay, so pause the video again and see if you can think through or write down what each of these words mean to you, and then we'll discuss them. So in algebra, we're often asked to simplify equations or expressions. And all that means is to go through and see if any of the terms can be combined, if any of the fractions have parts that can be cancelled out, anything that makes the whole expression look simpler. So the analogy with words would be if we have a sentence that's said in a very convoluted, complicated way, where the same thing can be said in a much more straightforward, simple way. So we would call that simplifying the sentence. In the same way, we can simplify mathematical expressions. So write it in a way that means the same thing, but with a lot less numbers or letters. All right? Now, solving means that you actually use the information given to find what number the variable represents. So if I have something like x plus 3 equals 0, I can solve that by saying that, well, that's the same as x being negative 3. So because I'm finding out what x actually is, that means I've solved for x. All right? So rearranging is actually what I did to this equation in order to solve for x. So it's just moving terms around so that the equation still means the same thing, but is written in a different way. So that's where all of our rules come in, that whatever you do to one side, you have to do to the other side, because you don't want to change the meaning of the mathematical sentence. All right? And then making x the subject is where we rearrange in a way to make a particular thing by itself. So I can say that in this equation, I rearranged it to make x the subject. So to get x all by itself on the left, so my end equation is x equals something. That means that x is now the subject of the equation. All right? And finally, we have substitution. So when you're told to substitute something, that means you take a particular value for the variable and you put that into your equation. So if I was to substitute x equals 1 into the equation y equals x plus 3, then that would look like y equals 1 plus 3, which is 4. So that's substituting this value for x in for the variable, so replacing it. All right? So to summarize, you've probably heard of maths being described as a language, and that's exactly what we need algebra for, is to be able to translate between our normal language, like English that we use to describe situations, and be able to translate that into maths that we can solve and that we can describe very precisely. So once you understand all these words and all these algebraic processes, we can use them to do really interesting maths, which is what I get really excited about. So I hope that helps clarify things and kind of cement all these words that you've been using and seeing used in textbooks and by your teachers. So let me know if you have any questions in the comments below. Otherwise, you can always find one-to-one help at candoteach.com. Thanks for watching, and I'll see you next time. Bye for now.